Our next speaker is Slink, and Slink will talk about something that is quite nice for me, because I have a server, and on my server I have some network services, and they are usually used for web applications, and they need to be protected by a firewall, or should be, and he's talking about an approach of using or establishing a firewall, and why the usual way how it's done today is totally wrong and flipped over. And I really love to hear it. So please.
Thank you, NervoFix, for the nice introduction. Welcome, everyone. Thank you for coming. I was expecting like 5 people shortly before shutdown, so really appreciate some people in the room. I'm obviously an old guy, started quite early with Linux, and I must say I really learned everything I know from FOSS. I am so grateful to all the FOSS I could learn from, and now being old, I kind of try to give a little bit back. Since 2009, I am an independent developer and consultant with a small company, and at the moment I am one of 3 maintainers of the software Vinyl Cache, which had a different name before. It's going to come up. And my bread and butter business is to look after configuring, customizing, improving this software for CDNs and usually larger websites. I have this principle: I do not talk about my clients. You know them. That's all I want to say. What's coming up could be qualified as someone talking about something they don't really know, because I'm a FOSS person. I have this perspective of this reverse proxy software. I do have first-hand experience with commercial cloud WAFs, namely Imperva and Akamai, but I do not have first-hand experience with a lot of other commercial software. So please, when you listen to me or read this, bear this in mind, that there may be things I just don't know because I didn't want to know. I want to talk about how things work, not about specific products. I am going to mention my Homebase project. Please forgive me. That's just the bubble I live in. That's just what I do every day. But I think the principles, the thinking about behind this is general, and I hope you will all be able to abstract from code in some arbitrary language to code in whatever system or language you might want to prefer. Why this matters to me. 2 years ago, I stood on the stage ranting about the cloud, and that's kind of a similar topic here. I honestly want more people, organizations, and even states or super states to become digitally sovereign again. And I know it's a contended expression or a contended matter, because people understand different things when they talk about sovereign. My understanding is I want people or organizations or whoever to be in power of the technology they use, and I want them to be independent of the tech oligopoly that we kind of converge to. I think in terms of domain names, Cloudflare dominates 80% of the internet. That's at least the number I know. It's debatable, also because of the metric, which is debatable. But anyway, I think it's totally clear that this is no longer a decentralized internet. We are living in the age of a centralized internet. So I want to help everyone, or at least give options to people by making available tools which are otherwise only available in commercial CDNs. And I really want all the stuff that I do to be enterprise grade. I know I hate this expression, but I'm using it because you probably know what I mean. I want the stuff to be like super efficient, absolutely reliable, doing the job. And WAF functionality is, I think, a key component. And I pondered this for a very long time and still do not have the solution, as you will find out. But I want to do the right thing. I don't want to go the route which has been taken so far. So just because this is my home base, I'm super curious, taking the opportunity, quick show of hands, who of you has heard of vinyl cache? Can I have some hands? Yeah, a couple, thank you. And who has heard of varnish cache? Yep, okay, it's kind of confirming my expectation. So yeah, we have renamed the project. The open source project has been renamed. The name Varnish Cache lives on as another open source project, which at the moment is downstream of Vinyl Cache, run by the company with the same name. Why do I love this project? We are super fast. We have a domain language called VCL. It's kind of what everyone does today with WASM at the edge, with edge computing in general. VCL, when it became available in Varnish Cache 20 years ago, was kind of the predecessor to all this edge compute, because we then started to have available a way to safely, securely run code right at the edge, at the point where servers are talking to HTTP clients. VCL gets compiled into machine code, first to C, then machine code, but it's no longer the real killer, because I mean people are used to running JavaScript and Python and WASM at the edge. Now I think observability is really important, and the amount of flexibility that we have with all the modules that we have to extend core functionality. But again, all I'm going to say, I am convinced, is by no way specific to this piece of software. And if by chance you learn something today, I will hope and am sure that you can apply it to other software. So, quick outline to get you oriented. What I'm going to talk about: firewalls and WAFs, HTTP, signed URLs, regular expressions, and the relevance of HTTP caching, very briefly. So, let's start with the basics. Why do we have firewalls? If all our computers and application software were safe, we wouldn't need any firewalls. Firewalls are an independent instance, ideally a different piece of software, ideally configured by different people to prevent FOPs. Everyone knows this. Do not tell me that your server software is secure. I mean, I make a living of this. I hope we all agree on this. So now the argument is, but hey guys, your software is also imperfect. And that's absolutely right. We had so far 19 security issues that we published in, I think, 20 years. So it's a pretty good record. But yes, even we have security issues. And for the C haters, they are not C issues. They are things like passing things wrong and stuff like that, which can happen in every language. So what is a network firewall? I probably shouldn't need to mention this. I do it anyway. A network firewall is a stateful layer 4 router with filters. And the basic algorithm is you look at a packet, you check if you already know about it. If you don't, you check the rules. And the rules, they look at layer 3 and 4 information, so IP addresses and ports in the case of TCP and UDP. In the case of obscure protocols like ESP, you would probably look at other fields. You have stuff on top. You can rewrite addresses. You look at sequence numbers, rate limit stuff, can shape traffic, etc., etc. I, again, hope that you all know this stuff, at least on this level. So how does a typical network firewall look like these days? We need DNS. Most of it is still on port 53 UDP. We need HTTP, which is, I forgot AD, sorry. 443 TCP and UDP for HTTP3. you should allow some ICMP for path MTU discovery. Most firewall admins still these days destroy it, make it unusable. Maybe you need SMTP, and that's basically all in most cases. And incoming traffic, if you run a server, you will probably want HTTPS incoming as well and deny everything else. And this really, really, really should be like common sense. Everyone in IT should know this, right? At the end of the rule set allows specific things, and at the end there's a deny all. And that is, yeah, really not debatable, I would say. And this is called a positive security model, because we make a positive definition what we allow, and the stuff that we deny is implicit in the fact that we didn't allow it. So, but this whole thing is kind of broken. Today, network firewalls are not sufficient anymore. The common rule set is, like I just said, basically deny everything but HTTPS. So all the traffic is HTTPS anyway, and we start to see people layering everything on HTTP, because that's the stuff that gets through firewalls. So we're kind of, it's a vicious circle. We can't do stuff at the network firewall layer anymore because people don't invent IP protocols anymore, because network firewalls block everything but HTTP. And now we even see stuff like media streaming over in this case QUIC, because it gets through firewalls, and also we cannot look at things because everything is encrypted. Now even we have encrypted client, hello, ECH, so that not even the host name that a connection, in this case an HTTPS connection is going through, a TLS connection is going through, is visible anymore. For good reasons, surveillance states, etc., but still it's a fact. So, what do we need? We need a web application firewall which does the firewall thing, not on the network layer, but on the HTTP layer. And this is like the super simplified illustration which I found years ago. Yeah, we want to keep the bad guys out. That's the basic principle. What does a WAF do then? It acts on clear HTTP. It cannot act on TLS usually. There are exceptions. I do not know this stuff, but apparently there is something called JA4, which is patented and proprietary and yada yada, which can do some fingerprinting on TLS. But that's really, I have never seen this stuff in real life, and that's obviously it's not. There's not that much you can see from TLS traffic except for side channels and stuff like client hello, which is now being encrypted. So if we want a firewall, we need to inspect HTTP requests. Usually the requests are the important stuff. We can also inspect the responses. And really, I think the most logical way to do this is at the origin. On the server where your application runs, you have that's really the best place to look at your traffic. But for reasons, people kind of stop doing this. And the next best option from my perspective is you put it in a proxy that you control, which in my case I advocate for using Vinyl Cache, but you can use other software. And then, because that proxy is under your control and you don't care, you shouldn't really need to care about encrypting between that proxy and your application. And then really the least best option, I think, is to run this stuff on a CDN in the cloud. And just to re-stress this, I hope many people will not have a doubt about this, but just restate, because I heard people not understanding this. A CDN virtually always implies re-encryption, which means we basically break TLS, because there is now a third party which knows everything about your traffic, all your traffic. Your passwords, your logins, your bank account data, whatnot. A CDN these days there are in principle tunneling options and stuff where you don't break TLS, but what people understand is the CDN is an adversary in the middle as a service. which is one of the reasons why I think it's a better idea to run this stuff on infrastructure which you control. So now let's get to the common models for WAFs. Then there's a negative model, there's a self-learning model, which some people like apparently, and then there's the stuff which I think is the right way. So what is the wrong approach firewall? It follows a negative security model. We identify all the bad stuff and block it. So it is literally as trivial as if the string bin bash is contained somewhere in the request, it must be evil. Look at the code. The link goes to the core rule set, which is basically still the baseline standard for negative security model firewalls. It's all there. I'm not making this up. And just to help with a little rage bait, you're not supposed to be able to read it, even though technically I can if I move close enough to the screen. But this is one single regular expression, one single line, which is supposed to find all the remote code execution in your web traffic. And that is not, again, look it up. I'm not making this up. And that's not the only one which is in this rule set. There are several. Okay, so let's stop the rage bait. It's generated. This is not the source that people added. You better not. But case in point, this stuff is complex. Don't tell me you just want a simple WAF. Don't tell me you just want to get rid of the problem. This is not the solution. I mean, it cannot be. I mean, at least to me, when I see these things, it's obvious to me. It might not be obvious to other people, I apologize, but to me, it's obvious. So what is this wrong approach? Let's elaborate a little bit. The illusion, the sales pitch is, it just works. But then it doesn't. Because then it blocks your legitimate traffic. Then your users open tickets, call you, whatever, and tell you, oh, if I go click, it doesn't work anymore. So what do? You look at the logs, you find out, oh, it's rule AB123. I'll disable rule AB123. Obviously, it doesn't work with my application. This method can only work for existing attacks. The rules. You must have as little rules as possible, because if you have more rules, less thing will work. So you need a small amount of rules which are as tailored as to existing attacks as possible. And then modifying the attack just slightly may circumvent the whole thing. There are countless cases where you can bypass WAFs by just adding another layer of URL encoding, by just putting the URL encoded stuff again in base64, and the application is so smart to unwrap all this, and then you hit the thing. It's obviously slow, because if I run like a dozen of these regexes on every single request, it must be slow. And there's this hidden complexity, which I always already talked about. And this slide is kind of a repetition, but I kept it in. There's this simplicity illusion. This gives you a false sense of security. Your manager will come to you and say, oh, we need more security. Put in something. Solve the problem. Yeah, you've put in the WAF. Yeah, fine. Now there's this false sense of security, because people assume that now you're safe, right? You've given Checkpoint $20,000. Now you must be safe. But in practice, what happens is you disable the very rules that are meant to protect you, and you open new attack vectors, or you open the attack vectors again. Also, lots of rules don't apply to the software. If you run your Java application, you will still get the rule set for all the PHP stuff and the shell injection, the RCEs using shellcode and stuff like that. It has this high internal complexity, and again, it can only be reactive. So, self-learning. This is something I have literally zero personal experience with. But I think what's happening there, at least to me, again, is so obviously wrong that I don't understand why people still say that this is a good idea. So the basic idea is you put a black box in your HTTP path and let run your traffic for a while. Then you have some software which looks at this traffic, generalizes it. So if there's a query parameter which has the value 1, 2, 3, and 4, 5, 6, sometimes it's pretty obvious that we probably can generalize to, oh, there must be a decimal number there. You do this kind of generalization, and then you turn that thing on. But what if you trained on adversarial traffic? Who tells you that you have not already seen the bad traffic when you trained the thing? And then also there's this sensitivity dilemma, because it's also blurry. You kind of have like a big slider that you turn more to negative and more to positive. And you answering questions like, why did it do this, becoming increasingly complicated to answer. And then there's the variant where you cannot answer these questions anymore, because they are in some neural network. I really don't want to comment on this. Again, this is like on the level, on the scale of things which seem obviously wrong to me. They're really at the end. There is no magic solution. It won't work. So, after all the rage, what is, at least in my opinion, a WAF done right? It must be a positive security model. Allow all known good and deny everything else, or maybe even modify the request such there is no bad stuff in there anymore. What you get is, and I know this is a kind of a big claim, you get protection against 0 days for free, for nothing. And this is, excuse me please, but this is my personal experience. There was, for instance, a time when we have a couple of clients where we have vinyl configurations which are like not marketed to the internal IT department as being WAFs, but they are WAFs, just the way we have set them up. And there was a time when there was really one PHP CV after the other, and in all these cases we could say, yeah, okay, we don't care. You don't need to patch immediately. You should patch, but no rush. It doesn't get through. The other pro, from my perspective, because I look at making websites faster and CDNs faster, caching gets better if you don't get any variation in how your request looks like. And stripping of this variation in how your request looks like is exactly the same thing you want to do for a positive security model WAF. Obviously, there's also a drawback, and the drawback is this either needs to be designed in, or if you want to retrofit it, you need substantial effort. You need to really reverse engineer how the HTTP traffic of your application is structured and what legitimate requests look like. Okay, so now let's get to some fundamentals. Like I said, I would be happy if you went out with a little more knowledge than you came in, and I also want to try at least to address this to people who are maybe just starting. So let's start with the basics of HTTP. What does an HTTP request response cycle look like? Here on this slide, the greater sign stuff is the request, which the client sends to the server, and the less than sign is the stuff that the server responds with. And this is HTTP version 1.1. I will tell you why in a moment. How does a request look like? The request is the top part. There's a method. In this case, most common methods are get or post. There are others. Then there's usually a path. Something else can be there. The protocol version. Then there's a header, maybe a body. The body of the request is stuff that you upload. So it could be a real upload, like an image video upload. It could be a form that you submit. It could be an API request that your JavaScript sends. And then a response comes back. The most common response is 200 OK, which means everything's fine. Then you have headers again and a body, and the body is usually what people think makes up the web. That's the actual data, the HTML, the image, etc. There is some more complexity to this. For instance, the request line can, in the second place, have basically 4 different things. The origin form is the standard one where it's basically a path. Then there's the absolute form where you actually have HTTPS / in the, the authority form, which is just the host name, and a star, which is only used for HTTP options. And then an important element of the absolute path in the origin form is that it has a query, these get parameters or query strings that you probably all know, separated with a question mark. And then the response has basically the relevant part is the HTTP version and code in the status line. And then we have these headers. They are separated field and value, and they look basically the same for request and response. So main takeaway. People make all this fuss about HTTP 2 and HTTP 3. And this is the same. It's absolutely, literally the same for HTTP 2 and 3, except for the encoding and except for framing headers, content length transfer encoding. They are relevant for, they still exist, but anyway, they do not serve the same function as an HTTP 1.1. But all the other headers, they are the same. So you can always translate back to HTTP 1.1, and you're basically doing the right thing. And just to make clear that this is not so simple, you can look it up in the RFCs, but just for the target, the request destination, the path, the URL, there are definitions about which characters you can use there. And one of the gifts I keep on giving is this percent encoding, this URL encoding thing, where you can write percent hex for each byte. This is interesting because it's mandatory only for some characters, but most servers accept it for all the characters. So that's one of the standard ways for adversaries to hide stuff they don't want you to see in your logs, and that they don't want your WAF to understand. Oh, and about the header fields, they can basically contain any data except the delimiters, which is also makes it also interesting. So, what's the problem with HTTP, and why do we have WAFs? The clients can send anything. They can do whatever they want, and you basically have every HTTP request is a big blob of untrusted data. And now you need to handle all this big blob of untrusted data and make something of it. So what are possibilities that we can handle this untrusted thing? And one concept which I think is still not well enough known is signing. Using cryptographic signatures appended to things so that we can know, not guess, not pattern match, that we can know if that's valid under the assumption that we haven't leaked our signing key or our shared secret. So if seeing this from the other way around, if we sign something, if we put a signature to it, as long as we are the only entity knowing the secret that has been used for the signature, we can it's basically guaranteed that no one outside can make this kind of signature. The basic format is always the same and very simple. There's the sign part, then some kind of marker, then a signature, and maybe an unsigned part, because sometimes you deliberately want stuff to not be signed. That leaves you then with the problem we're going to talk about next, but still you need it. When we talk about signing, I don't want to give an introduction to cryptography, and also I'm not a cryptographer myself, so I want to stay in my realm. But the basic things which I think you should know about using signatures is that there's a symmetric way and an asymmetric way. The symmetric way is good if you control both the signer and the verifier, because then you can use a shared secret between both, which is the whole point about being symmetric, that you have the same kind of password for both ends. But this also means that the verifier can always also make signatures, right? Because it's symmetric. So from a security standpoint, only use this if you have both these components under your control. That could be like if you have your vinyl cache and your application, the application makes signatures and the vinyl cache verifies them, and you both have them in your own in the setup that you control and you only control. Then use this, because these signatures are super fast, like millions per second on a CPU core. So they are not by any means not the source of your performance issue. At least if you have, unless you have the implementation in Python or whatever. But if you have a native implementation, they are super fast. And then there's the asymmetric stuff, elliptic curve cryptography, or the good old RSA, where you have, because they are asymmetric, the signing instance and the verifying instance, the verifying instance does not need to know the secret, the private key. You can basically verify everywhere and just sign in a protected place. And then there's post-quantum. I have no idea. I mean, sure, I'm following blogs, but I do not understand what people have really settled on, and I don't want to talk about something I really feel I don't know enough about it. For just one very, very important thing. In crypto, there's this saying, don't roll your own. If you want to use symmetric signatures, signatures based on symmetric hashes, based on hashes, always use an HMAC. Because otherwise, the simple answer is your signatures are guessable. What does an HMAC do? It basically adds this password to the hash function. So it turns your hash function into something you can actually use for signing. And this is algorithm agnostic. So an HMAC is always an HMAC, no matter if you use it with SHA-256 or it's even, as far as I know, it's even still secure with MD5. But don't trust me with this. I use SHA-256. So now that we heard about signatures, what can we do with them? A very basic concept is just simply sign the URL. Have for the request path, and to path with the query parameter foo equals bar, append another query parameter for the signature. And this already gets you so far. This is really like amazing what you can do with signed requests, signed URLs, alone. It's really amazing, because basically now you get the guarantee that there cannot be a valid URL which you have not created. It cannot exist. People can no longer guess your URL. It's cryptographically, quote unquote, proven impossible. If you don't leak your signing secret, people cannot make up URLs. They need you to provide the URL that they can access, you being your software. And another example, little story aside, I use this for our project for JO on code vinylcache.org. which is it's signing. It's a bit of code to sign cookies. So the basic idea is the application doesn't know anything. It sends a set cookie response header. We put a signature at the end of the value of the cookie. The user agent stores the stuff because it's opaque anyway. So user agents must store it as received. On the next request, they send back the cookie. On the proxy, we we first validate the signature, and if it validates, we strip it off, and otherwise we just drop the cookie. So that's another I think, super nice, easy, elegant way to just solve the problem full stop. People can no longer make up cookies. And now the next step is really what I think, as far as I understand in the industry, is called a web token, which is the same thing. It's a signature added to something, but also with the timestamp. So now the signed thing has a lifespan. It's like a lease. You grant someone the right to access something, but the right expires at that point in time as defined by the timestamp. And again, this cannot be forged out from the outside because of the signature. There are famous example is JSON Web Tokens. Another thing which I worked with is Akamai auth tokens. Where are they used? Usually in content delivery, content protection, as it's called sometimes. So when you use your video streaming XYZ service, you're basically almost guaranteed that the video streams are using token protection. That the URLs that you can use to play video content expire and have a signature. But that's not the only thing we can do. We can also generalize to securing websites. What are JSON Web Tokens? I didn't introduce that yet. They have a JSON. They're basically two JSONs and a signature. One is a JSON header, which has meta information about the token itself, and then the JSON payload, where you can basically do whatever you want. It's just JSON. It's base64 encoded and signed, and that's your token. Very simple. And people make a fuss about JSON Web Tokens, but you can roll your own implementation in except for the cryptography, in 20 lines or so. You can even do it in Bash and awk and etc. So just to illustrate this point, I built a CDN. It's publicly accessible, but it has private content, so it's meant to only be used by people from this corporation, which uses JSON Web Tokens as the URL. Super, super simple. It looks awful because there's absolutely no meaning in this gibberish, except for the fact that if you look closely, it almost looks like my real first name was in there. Many of the JSON Web Tokens have N-I uppercase I-S in there, which always looks like Niels. They look awful, but they're super convenient because now you have structured data in your URLs. And you have implementations everywhere. There are JSON Web Token implementations for everything you can think of. So, where are we now? We have ideas how we can solve the problem for real. We can have the ideal WAF where access is only possible to objects with cookies which were explicitly allowed by us, the application. For this scenario, we could build, like I said, I built a CDN, so I know for a fact that I can build whole websites with just this, except for a very small set of entry URLs, your slash URL for your slash path for for accessing the homepage of the site, that will probably not be signed, right? But you can in theory do this with a very low number of exceptions, and theoretically everything after that could be signed. And what do we get? We get basically, in the case of my CDN, I claim towards the customer and still stand by this claim that this has 0 attack surface. It's not quite true because sure, the software itself can still have, like in this case vinyl cache, it can still have security issues, but at any rate, the attack surface is like converging to 0. It's super, super small. But as I hinted at in the beginning, this optimal case is really hard to do unless you do it right from day one. If you design a new CDN, you have this once in a project lifetime chance of getting this right. And as soon as anyone has established anything which is not signed, you're basically lost, because then it will proliferate and people will just keep on and on and use the shit again. So excuse me. So other than for this ideal case, the real world is messy, and we need pattern matching. We have applications which work the way they work, and if we want to improve security with a good WAF, we need pattern matching. And pattern matching, for all practical purposes, means regular expressions. And I can only give you this advice: master them. No regular expressions. They are just amazingly useful for almost everything. I'm going to give you some examples. So, quick quiz. Who of you, hands up please, thinks they know regex reasonably well? Yeah, okay. That's good. I'm glad. So, to those who just raised their hand, what would you think is the regular expression equivalent of what you know in the shell as // the glob pattern, which matches all the directories which have in a certain path? What do you think is the regex for this? I don't want to keep on with the quiz because I think that's unfair to people who, I don't want to shame anyone, right? So, but you can maybe answer your question, answer the question for yourself silently. So in the following examples, just to clarify, because there's a lot of languages starting with Perl where / was the delimiter for the whole regex, like /regex/ was how you write a regex. In the examples that I'm going to show, I will not escape the /. So it's literally the regex. The reason is simple. This is how we do it in vinyl cache, right? There is no / is not magic in vinyl cache. So the // could it be this? People already shaking their hands, their heads. Yeah, it can't be this, because .* is everything, and that could include nothing. So this could also match // and that wouldn't be /*/. Could it be this? So now there needs to be at least one character in between the slashes, which is already good. But what's the problem with this? The character in between could also be /. So it could be // that's being matched here, which is not /*/. Next one, we exempt the /. So we match for everything between the slashes which is not a /. And at least one. That's better, right? We have / something which is not a //. That should be correct, right? Should be really the pattern for paths in URLs. Is it? I guess at this point, some people will really wonder, what could it be? Yeah, URLs can have a question mark in the end, the query parameters. And if we don't exempt them, the / can be somewhere at the right in the query parameters, and it would match like a path element, and we wouldn't want that. So something to take home as well. If you write regex on paths in HTTP, this is like one of the recipes which are really helpful. Back to WAFs. What do we need to do in the real world? We now need to run pattern matching against the HTTP request and maybe the response. So usually how this is structured is that you go by path, because things behave differently depending on the path. And for each path, you now need to check, is this a valid request method for this path? Should this only be get and head, or could it also be post or options or whatever? Which query parameters are allowed and with which values? Which request headers are needed and with which values? And optionally, you also might want to match the body data. If we've done all this for each HTTP request, checked everything, then we have really checked and possibly sanitized the untrusted data that the HTTP request really is. And then we have a firewall. Sounds easy, right? First problem that you encounter, large-scale matching. If you have a naive go at it, you end up with a ladder of matches. So check the first pattern, do something. Check the next pattern, do something. Check next pattern, do something. So obviously that'll work for this example. It will even work for maybe 100 URLs or so. But at some point, this will break down and be just extremely slow. And I wouldn't be talking about it if we didn't have a solution, which are sets. We have them in several flavors, and other languages have them too. This is really what you should use. This example is for Selector, which is a custom matcher that we have, but the example would look almost identical for Re2, which is a matcher library which is almost regex. It's not quite, because it doesn't have some things which usually you don't need. It has these sets, so how do we get out of this ladder? We run one big pattern matcher against the string that we get presented, and then we make our decision, and making the decision in this case means call some code. And then that code handles this specific sub-problem. So now, at this point, we've already made the problem substantially smaller, and then we handle the next level of that problem. So why is this important? It reduces the complexity from n times L, so number of matches times the length of the URL, to just order of length of URL. Why? Again, I keep on advertising my home project. Please excuse me for doing so, but in VCL, I think what's really cool is that we can call code, like I just said. We don't need to like have another table or array or whatever. We can just call code. Next thing, if you think back to how HTTP works, there's the request line, which has basically the URL and the method, and the next part are the headers. We wanna on a positive security model WAF, what we really want to do is we want to define which headers are okay, and everything which is not okay must go away, must be dropped. I hope you can already see by this way of thinking how this really solves the problem. Because if your attack tailors my custom application header having a specific magic value, if we don't have that header, what can go wrong? I mean, seriously, it's no longer an attack vector. So this is again vinyl code for doing this. This just leaves the host, which you probably need to check anyway, the host name. You really should check that anyway. Except encoding is let pass, because that's getting normalized by vinyl cache to gzip, just gzip anyway. So it's either nothing or gzip. And the conditional request headers, if modified since, if non-match, they are the request headers which are used in GET requests to, by chance, get a 3 or 4 not modified response, which is shorter because it doesn't have the body. That's basically cache validation for the client. And then last thing is the body. This example is not great because we used it for the response body, and I was right now talking about more the request. But please forgive me, I'm mentioning it because I think it's such a cool example. This is a regex which checks if something is an image. And it doesn't check this in the way of is it an image, does it really pass, does it decompress, is it really valid, does it have a good color scheme, is it maybe CMYK when I only want RGB? No. It only checks the magic string at the beginning of the object. So it's basically answering the question: does it look like an image? A bit like file on Unix BSD, whatever you would look at the magic in the beginning of a file. And why do I think this is cool? Because these are regex, these are regular expressions. And many people don't think about regular expressions being used to match binary code, but binary code to the regex engine is just the same as text, right? It doesn't matter. I don't have the tutorial ready for this, but my colleague is working on it. You can look at the PR or just follow us, and then we will notify you. So what do we have now? We have all the building blocks that we need in basically just 3 slides, because we had one slide about the request, and we had one about the headers, and we had one about the body. And with just these 3 tools, you now have all the building blocks that you need to build a great WAF. The hard part is doing it for real, on a real application. I have some cases live where I used Python to generate something from a JSON definition, turn it into VCL. But really, my big problem at the moment is I would really like to see this happen in the open world, in the FOSS world. But so far, we have really not made this accessible. We obviously need generators. A lot of commercial firewalls already have generators for their WAF rules to translate from OpenAPI. What I would really like to have is some kind of generalization to web, not just APIs. And honest question, please don't answer now, but maybe in the questions or talk to me afterwards. I really want to know, are there any existing projects? Because honestly, I was looking for them, I think reasonably hard. I didn't find any. I really want to know, is anyone aware of a project which is kind of an open definition of a WAF that people can create for their framework, for their application, and ship with the application such that people can generate WAFs out of this definition? That I think would be really great. I like, positive security model WAFs, like the good ones. But now that we've understand that this problem is hard, there is some light at the end of the tunnel. So I'm going to show you on one slide, cheating because I'm using stuff that was on another slide, but basically on 2 slides. I'm going to show you a simple WAF which does the right thing and gives you like real good protection. It's gonna be keeping most of the stuff out, but it's also quite likely break your application if it's more than a block. But still, so what is this? Only allow get and head. Don't allow any request bodies, strip query parameters, all of them, and remove almost all headers. This is it. This is your WAF on 2 slides. We check if the host is right. We check the method, like I just said. We check if there's content length or transfer encoding, which means check if there's a body. We strip the query parameters, and then we apply this header filter that I just introduced. So last thing for today, I was originally planning to make this more elaborate, but I wanted to have a little bit of room for questions. So I'm only going to hint at this again. I already mentioned it before. By reducing the variance of the request in such a way, you also optimize for caching. And caching is kind of also a WAF. It's not really a WAF in what it does, but it's also a WAF in that it keeps the problems away. Caching is, with Wiener cache, delivering a cache response is still like 3 orders of magnitude faster than rendering it in whatever application. There are examples, sure. There are exceptions, sure. There are applications which are really efficient, but just as a rule of thumb, your application can maybe do 10 a second. We can do 10,000 a second on one core. So this makes you resilient against DOS, Mastodon posts, stuff like that. And yeah, so just not to stress it, this was it. Thank you. Big thank you from my side to all the people who make GPN possible, and also I must say and want to say that this has been paid for by the Sovereign Tech Agency in the form of a sponsoring of our work. We didn't talk about it very much so far, but we are obviously super grateful, and I really want to take this money to make this available to more people. Thank you.
Thanks also from my side. Do we have any questions? Okay, 1, 2, 3. Okay, some. I'm coming. Just a moment. Keep your hands up.
Thank you. You mentioned the sort of vicious cycle of building a firewall and then people build things intentionally in ways that get through firewalls. Do you think that is something that could also happen to WAFs, or are they immune to it because they are more customized to the application behind it rather than at a network level?
I mean, in theory, it could happen because people use WAFs also on the client side. So if you talk to people working for example, banks, you will learn that they decrypt all the traffic that originates from the computers used by the people working in the bank, run it through something like a WAF. In this case, the emphasis is more on finding leaked data and stuff like that. So like there, it's kind of already happening. But in my world and what I talked about, I was addressing the server side. So there really, I don't think how this vicious circle should happen there. But it did happen on this end with the firewalls, because the firewalls are deployed on the client side, and you want the clients to get through to you.
What's your take on WAFs for like normal-ish PC systems like OpenSnitch or something like that?
I'm not competent. Excuse me, I'm sorry.
Thank you for the talk. I don't understand how you block, so you allow specific parameters to pass through the WAF only, and how do you check that those parameters are not being exploited with malicious values? For example, still executing bash through a parameter or something? Yeah,
very simple. You just not only match the name, but also the value. Because the request line is just one single string, and also the request body, if you look at a post request, also the request body is basically just one long string, and you match that.
Okay, but does it mean that you need to map all possible values in a...
Yeah. And that's why I was talking about signatures, because mapping all the possible values is in many cases really, really hard. And you avoid that by having a signature. But then it obviously breaks if you have a free search form, for instance. If you want to allow users to just search for anything, you obviously cannot match all values unless you allow all values. And then you're back to .star.
Last question. How do you allow only legitimate users to be able to sign the request? Best thing is use public key cryptography, use RSA, and trust some public keys. So if you do for instance, if you validate your JOT, in many cases there is even a standard for how you get to the key, which is JOKS, JKS, I think. You basically pull the public key from a URL that you trust, and then you put that into your validator.
Last question here.
Can WAFs then also be used to modify requests, like I put a key in there or something like this?
That's what I was kind of implying with the examples. The example I gave you was filtering the request headers. It wasn't actually checking them. Filtering, I think, from my perspective, is in many cases much easier than throwing an error if something is wrong, because it also kind of reduces the things that can go wrong, which affect users.
So then, thank you. And I'm sorry we are out of time for more questions, but I guess you are still available after.
I'll be around. And again, I had this question to every one of you. If you heard of any standard, please really do get in touch or write me on Mastodon if you know anything. Thank you very much.
Okay, thank you. And a round of applause, please.